with the resistance of 5.6 ohms is connected together with a switch, an ammeter, and a high resistance voltmeter to a battery with an unknown internal resistance R. So this is an internal resistance of the battery. This is the voltmeter. Remember, the voltmeter has got a very high voltage, so there is no very high resistance. There is no way that current can split here. Even it's in practical, in real situations, it does split, but what comes here is very little, in such a way that is really makes no difference. Let me say maybe I'm having 14 amperes flowing here, right? So if here I'm getting 13.9999999 recurring, and here I'm gonna get 0.000000000 recurring, then 1 at the end, you see. So it makes no difference, because a voltmeter is having a very high resistance. So we have an internal resistor of a resistance of the battery. The dotted lines here symbolizes the battery. Then I've got a resistor, an external resistor. You can see there a capital letter R, and a switch here. At this point, switch S is open. Then the ammeter reading to read the amperes, the rate of flow of charge in this circuit. They say the resistance of the connecting wire and the ammeter are ignored. So the resistance of the conductor and the ammeter are ignored. The graph below shows the potential difference across the terminal ends of the battery as of the functioning time. So now the graph here is showing us how the voltage was used as the battery was used. At time 0, we started with 13 volts, right? At time 1, switch S is closed. So now at time 1, switch S is closed. So that means there's electricity running here, right? So at time 1, there was a drop in voltage. So now there was a charge that was flowing here. There was current flowing here, right? So 2 to 10.5. Right, so this is the maximum voltage that the battery can provide. This is our EMF, right? And this one is an electricity. This is a voltage that we are going to find on an external circuit. To an external circuit, the battery is providing 10.5. What happened to 2.5? It was used inside the battery. You see, it is the energy that is used inside the battery to move charge inside the battery. So there is 2.5 volts that is used inside the battery. So they say define the term EMF. We've defined the term EMF here. We said EMF is the maximum energy provided by a battery per coulomb of charge passing through the battery. Or you can just simply say is the maximum voltage the battery can supply, right? So now they say write down the value of the EMF of the battery is 13 volts, right? When switch S is closed, now switch S is closed, they say calculate the current through resistor R, right? So now I know the EMF of which is like for example, I know the voltage on an external circuit, that is 10.5. I know the resistance is 5.6, right? So what they want from me, they want current. I know the equation. Here is the equation. V is equals to IR. I know resistance, I know voltage, I want current. It is easy then to find out current there. Remember, current is measured in amperes, capital letter M. Then they want power dissipated in resistor R. You go back at the back of your question paper, you will find the equations there. You will find that P is equals to I think is IR squared. Or is I square over V, but you're gonna find the equations there, you substitute and you get your answer. The internal resistance of the battery, right? They want an internal resistance of the battery. I'm not concerned much about this one. because we haven't done power as yet. Let's come to this one, internal resistance of the battery. Here, remember we said there is 2.5 volts that volt is used internal the battery. So I know the total current because I know that the total current here that is flowing here, because the current that is flowing in this resistor is going to be the same as the current flowing through this resistor, because this resistor and that resistor are connected in series. You remember that one. So I know the current flowing in this resistor, I know the voltage in this resistor, so I can calculate the resistance of this resistor, because remember we said V is equals to IR, so I can calculate R knowing the value of V, that V is 2.5. Remember we said 13 minus 10.5, so we got 2.5, of which is a voltage that was used, the energy that was that's the a voltage that was used in an internal circuit of the battery. All right, now we got this one. It reads as two identical resistors. So if they say identical resistors, they mean these resistors got the same resistance. Their resistance is the same, each with resistance X. Now are now connected in a same circuit with switch S closed. So switch S, you can see switch S is closed, so there is current flowing here as shown in a diagram below. Right? An ammeter reading now increases to 4 from this circuit. They're putting two resistors here, right? They're putting two resistors here of resistance X and X. So switch S is closed. They tell us now that the resistance now the current increases to 4. What will be the reading? How will be the voltmeter reading changes? Choose from increase, decrease, or remain the same. What did we say? We said the relationship between the current and the voltage is at the constant temperature. The voltage is directly proportional to the current. So if the current increases, the voltage is going to increase as well. All right, and they say the next question is give a reason for your answer by referring to voltage internal resistance. So here they tell us that, remember now, let's say we had 2 ohms. This resistor was 2 ohms, and the voltage was the amperes at first were 2 amperes. So the voltage that was lost internal was 4. I'm making an example, was 4. Now the voltage in the amperes now is current now is 4, but the resistance remained the same as 2. So now I'm going to have 8 volts that are lost internal. So the voltmeter reading is reading here, right? So how much of voltage is going to be sent to an external circuit is going to decrease. So then here the answer is decrease, is not increase, is decrease. Why? Because the internal resistance has the voltage, because the voltage that is used inside the battery has increased, because the current that is flowing through the internal resistor of the battery has increased. That has increased the voltage inside, the voltage used inside the battery. So decreasing the voltage that is sent outside the battery. Again, how would the voltmeter reading change? The ammeter reading now increases to 4 because these two resistors are connected. Ammeter reading increases to 4. How the voltmeter reading change? The voltmeter reading is going to decrease. Again, the voltmeter reading is going to decrease. Why? Now here, give a reason for your answer referring to voltage internal resistance. Now, the current that is flowing through the internal resistor has increased, right? Increasing the voltage that is lost inside the battery. Again, the current flowing inside the internal resistor of the battery has increased, right? That increased the voltage lost inside the battery, right? Because V voltage is equals to current times internal resistance. Let us make an example. If the internal resistance of this resistor is 2 ohms and the current is 2 amperes, so the voltage that is going to be lost inside this battery is going to be 4 volts. Now the current increases to 4. We have a resistor of 2 ohms and a current of 4 amperes. So the voltage that is going to be lost inside this battery is going to be 8 volts. So how much is going to be sent to the external circuit if the current that is lost, if the voltage that is lost inside here is 8? Now is going to be 13 minus 8, and that is going to give us 5 volts. So 5 volts is going to be sent. So the answer here is decrease. Reason because of the increase in the current flowing through the internal resistor, increasing the voltage lost inside the battery. Now they say calculate the resistance X. So now they want to know what is the resistance of this one. Remember, these ones are in series. So add them together. You're getting 2X, right? And now 2X, this resistor, the new resistor that is 2X now, is in parallel with 5.6. You know how to solve the resistor that in parallel? Remember? You know how to solve resistor that in parallel. You know how much current is flowing here. You have calculated the current that is flowing through 5.6, the resistor 5.6 here. Calculate the current flowing through resistor R, right? You take that answer there. You figure out how much current you know the current that is flowing here. You know voltage that is flowing here. Or remember again, you are told that the current is 4 ohms here. This is 4 amperes. The ammeter now read 4 amperes. So the total current flowing here is 4 amperes. And now you know the voltage outside. Then you can calculate the resistance. You calculate your value of X, then you divide, you solve for X. You solve for X, then that's how you're gonna get your 5 marks. I hope you understand. If you have any questions, please go to your comment section, or you can email me at msabati@yahoo. We are going to discuss it at any means and try to make you pass physical sciences with flying colors. Thank you very much. Please subscribe to the channel and click the bell so that you're gonna get notifications anytime we upload anything new.